Hi everyone, in this video, we're going to dive into one of the fundamental building blocks of any programming language, basic data types, specifically focusing on numbers in Kotlin. Let's start with a key difference between Kotlin and other languages you might be familiar with, especially Java. In Kotlin, everything is an object. This is a significant design choice that reduces code complexity. Unlike Java, where you have a distinction between primitive types like int and their wrapper objects like integer, Kotlin removes this necessity entirely. So, from a developer's perspective, whether you're working with an int, a long, or a double, they all behave like regular objects. This means you can call methods and properties directly on any number variable. For example, you can convert an int to a char by simply calling a method on it, like code.toChar. Now, you might be wondering about performance. If everything is an object, isn't that inefficient? Well, Kotlin's smart compiler takes care of that. Behind the scenes, the Kotlin compiler optimizes these types. Whenever possible, number types like int, long, or char are actually stored and represented as primitive types in the compiled bytecode. This means you get the best of both worlds: the expressiveness and simplicity of working with objects, coupled with the efficiency of primitives at runtime. Let's look at the built-in number types that Kotlin provides. These are equivalent to Java's numeric primitives, but in Kotlin, they are full-fledged objects. Here's a list of the common number types and their bit widths. Byte, an 8-bit signed integer. Short, a 16-bit signed integer. Int, a 32-bit signed integer. This is the default type for integral numbers. Long, a 64-bit signed integer. Float, a 32-bit floating point number. Double, a 64-bit floating point number. This is the default type for floating point numbers. Now, let's explore how to declare number literals in your Kotlin code. You can declare basic decimal integers just by typing the number. Val mient equals 123. This will be inferred as an int. For long values, you need to add an L suffix at the end of the number. Val mylong equals 1234566L. This is a long floating point numbers are inferred as double by default. Val mydouble equals 12.34. This is a double. If you specifically want a float, you need to use an f or f suffix. Val myfloat equals 12.34f. This is a float. Kotlin also supports other numerical bases. Hexadecimal literals use the 0x or 0x prefix. Binary literals use the 0b or 0b prefix. It's important to note that octal literals are not supported in Kotlin. Next, let's talk about number conversions. This is another area where Kotlin differs significantly from Java, and it's designed to prevent common errors. In Kotlin, there are no implicit conversions for numbers. This means that a smaller type, like int, will not be automatically converted to a larger type, like long, without you explicitly telling Kotlin to do so. Let's look at an example. Var weight, int equals 12. Var truck weight, long equals weight. This will cause a compilation error. As you can see, the compiler immediately flags this as an error. This is because Kotlin requires you to be explicit about your conversions. To fix this, since all number types are objects, you can simply call a conversion method on the variable. Var weight, int equals 12. Var truck weight, long equals weight.toLong, correct way to convert. The Kotlin standard library provides a suite of conversion methods for numbers, such as to byte, to short, to int, to long, to float, and to double. While this might seem like more code initially, it actually helps you avoid many subtle bugs and saves a lot of debugging time. This explicitness is a core part of Kotlin's pragmatic design philosophy, making your code safer and more predictable. To summarize, Kotlin's approach to numbers is designed for simplicity, safety, and performance. By treating all numbers as objects while optimizing them to primitives under the hood, and by requiring explicit type conversions, Kotlin helps you write robust and maintainable code from the very beginning. In our next video, we'll dive into Kotlin's next component. So, see you guys in the next lecture.